This lesson's called Solving Problems Involving Rates of Change. And you know what? It says solving problems, and that's not quite accurate, actually. We're going to learn how to solve exactly one problem. And that's good news for you on the test. You're going to know what's coming. There won't be any surprise here. There's one particular problem now using rate of change that we can solve using the methods that we've come up with so far. A little setup. Let's just talk about maximum and minimum values. Let's consider the following sections of two graphs, one which shows a local max and the other one which exhibits a local min. So I've just got a simple maximum and a simple minimum. That's all. I'm just trying to prove that it's sort of the same. The thinking that has to go on here is the same whether it's maximum or minimum. So here's the question. What is the slope of the tangent at the local max and min? If I were to draw a tangent line at both those max and mins, what kind of slope would you see? It's zero. It's a horizontal tangent. Big moment in calculus. And I say in calculus because we're in there now. We're right in the depths of calculus right now. The big moment in calculus is that, oh, right at the top there, the slope of the tangent will be zero. And I draw a little picture of the slope. Do you have the pictures of the slopes in your note? Yeah, it's already there, saying, okay, there's the tangent line at max or mins. And we really care about max or mins. I got to tell you, no matter what field you go into, biology, chemistry, certainly finance, you care about when you reach the maximum, and you certainly care about when you reach the minimum. These are important points on the graph. We can use this idea that the slope of the tangent where a local max or min occurs is zero to help us solve problems. Yeah, problems. For us, in this chapter, one particular problem. There's only one problem we're going to be able to really solve here so far. It says, show that the minimum for the function x squared minus 4x plus 11 happens when x equals 2. Now, a little background on this particular problem. To find out that that the max or min value happens at x equals 2, you already could do this in grade 10 or 11. And we did it last chapter by completing the square. The problem with completing the square, besides the fact that it's a giant pain, is that it only works for degree 2 functions. As soon as there's degree 3, as soon as it's x cubed, x fourth, x 5, any other degree, complete the square does not work. And not even doesn't work. It doesn't even work a little bit. It's useless. Okay? So you could go back and do this question by completing the square. But using what we've learned here, there's a more powerful method. The more powerful method is to say, okay, that's what it says here. We could find the vertex of this upward opening parabola and show it has an x value 2. Well, let's use our knowledge of slopes to get us ready for tougher functions. Degree 3, degree 4, degree 5, exponent 3, exponent 4, exponent 5, whatever. If a minimum does indeed occur at x equal 2, what can we expect the slope of the tangent to be where x equals 2? We're expecting 0. We should see a 0 slope there. Thank you. Everybody says 0. Good. If a minimum occurs when x equals 2, what can we expect about the slopes of the secants through a point x equals 2 and a point with x values slightly lower? What? It's a giant sentence that might mess you up. Yeah, I need to draw a little picture here. Minimum at x equals 2. Oh, here comes the picture. If there's a minimum at x equals 2, assuming if there is a minimum at x equals 2, and we find the slope of a secant from here and a point slightly left, if we just go slightly left of that, what kind of slope will you see? Will it be positive or will it be negative? It's going to be negative. It's almost a duh moment. This is the moment where you go, well, duh. Right before you hit a minimum, you'll be decreasing. Right? Pretty straightforward, I think. If you're about to go into a minimum, you should be decreasing as you come in there, so you're going to have a slightly negative slope. What's going to happen if the x value that you test is slightly right and it is a minimum? What kind of slope will you get here, positive or negative? Positive. It makes sense. If you're going to be a minimum, you should go from negative slope to positive slope. You should go from decreasing to increasing. That's what a minimum is, decreasing to increasing. These pictures, if you have trouble with these questions, this slide is perfect. It shows exactly what the plan is. Let's see if these conditions are met. So we literally just do it. We go, okay, we want to go slightly left of 2. Anything slightly smaller than 2 will do. 1.9 will do. I used 1.99 to really exaggerate the point. I find the slope from 2 to 1.99, I just sub in like we were doing in those tables. It's the exact same thing. Get my two values, and I get a secant slope of negative 0.01. Two things have happened. One, I got a negative slope, and it was close to 0. That's what I was hoping for. Small negative slope. Then if I go right, and you can do the subbing in yourself to see that these all, I just subbed 2.01 into the function, and I subtracted the two values, and I got 0.01 positive slope. Did we get what we are expecting? Did it go from negative to positive? Yeah, it did, and they're right around 0. Technically, there's two things that should happen. Negative to positive, and all the numbers should be close to 0. We should be right in around a 0 slope somewhere. In both cases, the approximation yielded results close to 0, one slightly above and one slightly below. It appears safe to conclude the slope of the tangent at x equals 2 is 0. When it says appears safe, your spider sense might tingle a little bit. So are you about to trick us on this or something like that? No, no tricks. When this happens, you're like, yep, it looks good. Are there problems that occur in this? And again, I hate to keep mentioning calculus, but yeah, there are certain situations and problems that could come up. We're not about to run you into those. My goal will be to walk up there and say, here's a point, here's a function, prove it's a max or a min. How would this change if I had have done, if this had have been a maximum instead of a minimum? What would the only thing that would have changed here? Positive and negative, that's all. So the min and the max, that doesn't really matter. In fact, I think the test question I chose this year, I just said, find out if it is a min or a max. You do the exact same procedure, except you don't make your conclusion till the end. You know, it's the exact same question, really. Also, the signs that secant slope indicates the function decreasing and increasing immediately after, which implies we have a minimum, not a maximum. I mentioned that when I was doing it. Therefore, we conclude that the minimum value does indeed occur when x equals 2. Yeah. And I went 2 decimal places really just to make sure I got a small number here, but 1 decimal place is usually lots. You know, like you just got to be slightly smaller and slightly bigger on the other side. Question for discussion. How would the solution differ for local max? Positive to negative. And here's a picture showing that minimums go from negative to positive slope, maximums go from positive to negative slope. And one more example, they want me to do it for 3 sine x and x equals 450. I'll do that in a separate page. So if you're like, oh, I sort of get it, but I'd really like to see it one more time, here it comes, start to finish. And actually, I didn't look to see if it said max or min. So I'm going to do the questions on the test. That's how I'm going to do this thing. It says, find if there is a max or a min at, was it 450 degrees? On the graph, and I forget what it said. Just 3 sine x, okay. Y equals 3 sine x. So, just 2 sides to look at. Slightly left, how am I doing on time? Oh, I'm really good. Slightly right. I need to tell you something about degrees. Degrees are really small. And you know what? Because I promise that there's not going to be any trig on anything until we get to the trig chapter. I'm doing a trig example here just to throw it in there. But I just want to tell you that you don't even need decimal places for degrees. Degrees are already really small. You think about 90 degrees. 1 degree, I don't even know if I can move my arm 1 degree. 1 degree, you know, like 1 degree is really tiny. So I don't even have to go to decimal places here. So I'm going to go slightly left. I'm going to go 449 degrees to 450 degrees. And on the slightly right, I'm going to go 450 degrees to 451 degrees. So most questions you should go to 1 decimal place, but here a degree is already really small. So m equals 3 sine 450 minus 3 sine 449 over 450 minus 449. That's just y2 minus y1, x2 minus x1. I've just subbed the 450 in there into both of them. And so the slope I get here is, if you're trying to get these answers on your calculator, make sure you're in degree mode. I hope that's come up in previous courses where you always got to make sure you're in degree mode. Is there other modes? Radian mode, yes. We're going to learn about that this year. Yeah? We'll talk about radians later. Not here. Exit. Okay. So the top, and again, you people with the fraction calculator, if you got a fraction calculator, you just type this all in as it sits. If you don't have a fraction calculator, you can type in all as it sits there, but you got to put a bracket around the numerator and the denominator. Watch out for that. It's an easy mistake to make. So decide right now. I've got the fraction calculator. A fraction calculator. When you hit fraction button, you literally get a fraction on the page. And you people can just type it in like you see it there. You don't need any brackets or anything like that. Those of you, I'm not going to worry about you. I'm going to worry about people who don't have the fraction calculator. They should type in 3 sine 450 minus 3 sine 449, close the bracket, divided by, open a bracket for the denominator, 450 minus 449, close the bracket, equals 0004569. I'm pretty happy. It's close to 0. In a minute, I'll have to decide whether we're talking about a max or a min. We'll deal with that in a second. To find from 450 to 451, exact same thing, except 3 sine 451, subtract 3 sine 450, 451 minus 450, and the slope I get on this side. Can I go back and change these? Oh, maybe, not bad. Backspace, backspace, 450. Backspace 451. This is now 450, so I gotta go 50, and this one over here is 451. Well, you'll get to know your own calculator exactly how you type these things in, and I get negative point, exact same thing. Okay, and this is like the test question. The test question says, it doesn't say whether it's a max or min. You've got to decide for yourself. But I went from small positive to small negative. From slightly increasing to slightly decreasing. What's happening at 450? Yeah. Therefore, a max at x equals 450 degrees. You see, complete the square would not have helped me here, because it was a sine function. But now any function they want to give us on the planet, it doesn't matter, as long as I got the equation, I can check if something's a max or a min. I can't, how did we come up with the 450? Someone's going to have to give me a hint on that. And we'll get to that soon. It's sort of what you were referring to earlier, is that you were talking about, well, we'll always be given the point. In this course, yes, we'll always be given the point, but later on, maybe not. Yeah, we'll work on that. Any questions about that? Did I keep my promise that lesson, comparatively speaking, was pretty straightforward? And easily predictable. The question on the test says, find if there is a max or min at some x value on the graph y equals some function. You know that question's coming. You can red star that and go, okay, there's 4 marks or 5 marks in the bank right there. I know exactly what has to happen there. Let's find it on last year's test. There it is. For the function, whatever, use slopes of secants to verify a local maximum occurs, x equals 2. It just, it's coming.